I will get on. Now you see the whiteboard. Yeah. All right. So I'm going to review normal distribution for some. You didn't do this at all. That's why you get trouble with this expectation part, with the variables part. So you remember that, right? So we want to tell Maria you didn't do this at all, right? Right, you probably do the join in 1 day unit. One when I do this. The unit one from Thursday or something. Right, so we should know about the normal distribution. The normal distribution, right? The parameters for the normal distribution is mu and variance. All right, but this could be an infinite number of distributions. So what they did is they standardize it. They standardize this to Z to a normal distribution with mean one. Mean what? Mean. What is standard? And mean 0 variance 1, right? So how do we obtain values now? Well, in order for us to get our probability values, we look kind of at the area under a normal distribution. The normal distribution is symmetric. So here is 0. Here is the positive half, here is negative half. What's the area under the normal? What's its total area here? If I were to add up every single thing here, that area is what? Right. So the probability underneath there is 1, which is equal to the area. Right? So the probability underneath all distributions there is 1. Right? And anybody remember like how far away is go? How far away from the normal is go? How far away from the mean is go? 3 standard deviations. Right? Any value beyond that 3 standard deviation, you'll get approximately, you wouldn't get anything. Right? So it's go kind of as far as 3 standard deviations. Okay? Anyway, so that's the area. You should know about the continuous distribution, and the area under the continuous is this. Right? If you go on to do stats later on, you will get to integrate this and actually work out those values. Very well fun. Right? Nice. How do we get values now? Well, we need to go to our Z tables, our normal tables, right? And to get the values in tables, you would recognize that all the values are, let's say you want to get the probability of Z is less than 0.1, right? All the probabilities are less than. So every single probability you're reading off, right, is less than. That's all here. So if I ask you to find the probability of Z is less than 0.1 or anything, 1.1, you go to a table and you read that value. Just go to a table, come on, please. Go to a Z table and you read off Z of less than 1.1. Right? Your first value is 1, then you go to the top and you read off the next value. Some way you get for Z 1.1. 0.8665. Yeah. Oh gosh, boy.
Second.
Right? 0.8. 643. Right. But so you guys not killing. What you have to do is not sit down all the way back from here, so there. Right? And if it's more than now, if they say the probability of Z is more than 1.1, right? I like to do this so you can see it, right? More than is here, more than this area here, here's 1.1. So you would see that a smaller area. Once you see the smaller area, hopefully some should click in your brain and you recognize that you're minus in the bigger area. One minus 0.8643. How much is that? Actually, do it in your head because that'll be wrong. 1,367. All right. Nice. So what? So when it's more than killing, you have to use the value from the less than and minus it off. Because the more than and the less than make up 1. So you minus 1, this from 1, and you get the probability. Right? What would have happened if you had the probability of Z is more than minus 1.1? What you say? When it's a minus, you have to remember this. When it's minus 1.1, this is the 0 line. So minus is here. Right? So minus more than minus 1.1 is all of this. Are you okay with that? More than minus 1.1 is all of this. And because it's symmetric, remember, if you go to a table, there is no minus on the table, right? So because this is symmetric, this is the same as these two are the same. Enough? These two are exactly the same. So for you to get the probability of Z is more than minus 1.1, all you have to do is find the value for 1.1. That symbol means find the value for. Right? That's okay? These two are the same. Are you okay with that? Right, just do me one quick favor. Find Z is less than minus 1.1. What will that be? No, do the sketch. Minus 1.1 is what? One of these values. So do the little sketch, Killen. Do this sketch for where you think minus 1.1 will be. Less than it. So what's same thing, minus on this side. Where is less than? Here, which is the same as this. See that? So that's the same as the probability of Z is more than 1.1, which is 0.1357. And lastly, that thing in physics, I sure that our teacher before. And the last thing we do yesterday, my mind, right? Talk about frequency thing. And then we do that before. So I'll just show you that quickly, right? My mind, right? Talk about frequency and then unit again. Right? I'll go over that. Right? Right. Suppose on the other hand, they said, what's the probability of Z between minus 1.1 and 1.1? Right? If you look in the, well, if you remember your unit 1, have formulas to these things, right? But we could also work it out. Minus 1.1 to 1.1. That's the end. That's the end. So how are you going to work this out? To work out this shaded region, all we need is less than 1.1 and this little area here. Correct? Y'all see that? This here is this same thing without this piece here. See that? What's it good? This area here is this whole area if I minus off this little piece here. This little piece here. So if I minus off this little piece, I will get this here. Okay with that? So what would it be? It will be that value 0.8643 minus of the little piece 1 minus of 0.1357, right? Which is the same as phi of 1.1, right? That's this actual value here, minus 1 minus phi of 1.1. Those who remember the rules, which mightn't be much people, you would see is the same as this plus this, which is 2 by 5 minus 1. So that's how they came up with the formula, right? But you don't really have to learn this if you understand how to sketch it. Okay? Are you okay with that? Okay, so that's the normal. That's a very normal work, right? Let's take a look at how to do chi-square now. That's a good idea. Yeah. How do we standardize now? How do we go from here to here? To standardize, you minus the mean and you divide by the standard deviation. That's the way to standardize the value. So like if you have like what we had last day, you can't read this off. You have to standardize it. So you're going to convert x to z and you're going to minus off mu and divided by standard deviation. Right? But the question will give you those things. Right? You will have it here. That's okay? So if I ask you, I give you a normal distribution, just like a geometry kind of person or whatever. I give you a normal distribution, right? And I say x follows a normal distribution with mean 10 and variance of 5 squared, right? And I said find let me be more realistic, 100, right? And I said find the probability of this, right? You have to standardize it to be able to use that table thing I'm showing you. How we standardize it? You minus the mean, which is 100, and divide by 5. And then you go to the table. Right? Sometimes now you have to work in reverse. That's not. Right? And then sometimes we had to go in reverse. Sometimes we had to go in reverse, right? What are you gonna do if you had to go in reverse? So let's say we had to do something like this. In fact, in unit 2, you know where to get it, sir. But you never know. Right? I'm gonna show you fast, right? Suppose I gave you the probability 0.8643. And I said, what is the probability of Z is more than some unknown? Let's call the unknown P. Find P. What you had to be able to do is to go in reverse, right? So more than, and you have a big probability more than a half, right? So what that means is whenever you use more than a half, you can't be on the positive side because more than is here, right? There's no way for this to be a positive value if you're on the right hand, if you have a probability more than 0.5. So it means that P have to be somewhere here. That's okay? That's the first thing I have to remember. Right? That's the first thing I have to remember. So P has to be a negative value. You okay with that? So now we have to be able to find P. So in order for us to find P, we know that this is the same as this. These two are the same. Right? So now you're going to the table, but you're going in reverse. You're going to this probability, you're going to the table itself, and then you're going backwards. So see what will give you 0.8643. So go in the table and look for 0.6843. Right, so go inside the table where you have the probabilities and look and see what corresponds to 0.8643. Yes, 1.1, right? But the answer is negative 1.1. Give it up. The answer is negative 1.1. Because remember, you can't be a negative off the table, right? But you put one negative, right? Six. But it moves like that side. Right. I know. But it is up, just do it and quick one. But we had to look at the mistake that I did with that. Anyway, so we're going to put two right hand rules. Right now, chi-square. Right. So if you remember, we did something called chi-square. And chi-square, you test to check and see about if the data you have fits a particular distribution. That's okay. So let's take a look at how to perform chi-square. What I have in the in this summary. What do I have in this summary here? Right. Take a look at this summary, right? I can't put it up because I don't have the my iPad now charging back there for physics, right? Look at the goodness of it. And the goodness of it, you have the particular distribution does provide a model for the data. Distribution does not. So you are testing to see. You are testing. Go on the chi-square. I'll say that. Go on the chi-square. And your H0 is the distribution. So I'll give you values. And I will say that this distribution follows a binomial. Right? And the particular distribution follows that binomial, and then the H1 is it doesn't follow. What's the rejection region? The rejection region is if a chi-squared test value is more than a chi-squared value from the table. Right? How you get test value? Observe minus the expected squared over the expected. Right? Anybody remember how to get the expected values? How you get the expected values? So depending on type of distribution, you find the probabilities. Right? And then you find the expectation. Multiply the expectation and work it out. All right? So let's target a few of these now. So you have to remember the formula from last class to find the probabilities. So if you have first one, you have to be able to find when the probability is 1 or 2 or 3 and so on, right? And then that will help you get your expected value. And then you work it out, then you work out your test statistic, then compare it with the values in the table. How you get the degrees of freedom? Huh? How you getting degrees of freedom? It's number of rows minus 1, right? Number of rows minus 1 or sometimes number of columns. All right, let's start one. Dexter, you have the past papers on the group, right? Dexter? Yeah, all right. So go to 2023. Go to 2023. Huh? 4B. 2023, number 4B. Take a little read, identify distribution, and then let's work it out. Some more items. Everybody have it, right? Huh? Can't say uniform. Sounding good? That fair die, right? All the problems is the same. Try it, please. Good still. Yes. Right, take a 10 minutes to it, and then I'll return it before, right? Right, you know? Yeah. Confidence. Everything on the chi-square. Everything on the chi-square. Right, so you had 120 truths, right? The observed values were 8, 12, 34, 32, 16, 18. Right? Expected, the probability will be 1/6, 1/6, and this 1/6 of this, right? Well, so the probability will be 1/6 is a uniform distribution, right? So I'll just fill in out this table one time. So 1/6 to 120 is 20. Okay. Right? And all they ask us for calculate the critical region. So let's do it according to what they ask us, right? Chi-squared is at 10%. Right? I'm gonna put 10% here. How much degrees of freedom? 1, 2, 3, 4, 5, 6. So it's 6 minus 1, right? How much is that? So you're going to a table, you will enough for 5, 10%. 9.236. All together? Yeah. So therefore, rejective what? Rejective the chi-squared calculated or test value. Let's test. Is what? More than? That's okay. So that's our critical region. The chi-square test value is more than this, right? We reject it. Okay with that? Then find the value for the test statistic. So in part 2, what they want us to do in part 2 is to find the sum of the observed minus the expected all squared all over the expected, right? They want the sum of all of this, right? So we know what is O minus E. I'll just square it one time, right? Square it one time. Right? So you minus them, that's 18, and you square it. How much you got? Huh? Oh, divide by E1. All right, yeah, you can do that. Man, let's just sum it up here. So how much you get? 7.2. Right? And when you sum it up, how much you get? 37.4. So we get, huh? Which one? For this one? Yeah, it's looking kind of wrong for truth. Look how close it is. Right, car? Remember, you're minusing these two, squaring it, and then dividing it by E. Right? That's where you get these values here. How much you get here? 0.8. So you can fix this, right? What you got? 28.4. So 28.4 is more than. So therefore what? Conclusion is we reject. That's fine. It's not going to be formal conclusion, right? Right. So we reject H naught at the 10% level and say that what? Say that it is not balanced. Right? Say it is not balanced. Are you okay with that? Did I have more in this one? Yeah. Part C, yeah. Do you think that? For sure. For sure then. Car, you okay with this? This is from the SBA, right? Well, we didn't have a uniform. Right? Car, this message lemonade again. Covered, right? If we get covered, that's lemonade. How would they get 9.3? Table. Table, put the chi-squared. Next. No, she knows chi-squared. She knows chi-squared. All right. Let's take a look at the part B, the part right underneath that. Right? I can pull it back up just now. Should have some charge by now. So now we have a discrete random variable. The discrete random variable x is uniformly distributed over 1, 2, 3, 4, 5. So they want to state the probability mass function of x. We're talking about it. And they want the little table. And they want the little table, 1, 2, 3. Yeah, the little table. Then find the expected value and the variance. Huh? Huh? Oh yeah, but just do the table and then get the expected, get the variance, and then follow it up. How we doing that? I don't understand that last part now. But we want to solve it probably. Yeah, I think we had to solve that quadratic most likely. For sure. I wasn't gonna tell you. Let's see what you come up with. Because you see everything inside the bracket. So from that, it will tell you what the two x values you need. Right? So do part 1, 2, 3, and 4. So we just make sure we do all the modules 2 in the order. So you just look back at the year and just make sure we do everything. Okay, supposing in the exam, you don't need the blank. Oh, you will not. That's what we want to make sure that. Two. There's four parts C, yes? There's four parts C. Oh, on, if I sure, if I sure. Yeah, the following table. Right, so what we have for the table. Check out the table command and do 2022 one time. Right, so we know X is 1 to 5, 1, 2, 3, 4, 5. And it's uniformly distributed. So the probability of each one is 1/5, 1/5, 1/5, 1/5, 1/5. Right? The one E of X is the sum of all the X by the probability, right? And then you have the last two parts to work out. No, the most of this way. Was done 2022 already? I tell her to do 2022 one time. Got a little bathroom stuff there in an article. Well. All right, well, let's track out 2023 and start 2022. Right, so they want the expected value, so it's 1 by 1/5, 2 by 1/5, 3 by 1/5, 4 by 1/5, 5 by 1/5, right? So this is 5, 3. And then they want the variance. Part 3, they would like to get the variance of x. Oh, wait, no, sorry. The variance of 2x plus 5, which is 2 squared by the variance of x. Remember, the 5 will be 0, right? So you got to go and find the variance of x. So remember that the variance of x is e of x squared minus e of x all squared. Right? How you work out x squared? You squaring this and multiplying by that, right? So you square this, multiply by this, square this, multiply by this. Same thing from the unit 1. But you got to pick the variance. 2 for the variance 2. So the final answer is 2 squared, which is 4. 4 by 2, which is 8. Right? 4 by 2, which is 8. Last part 4. They want you to get the probability of x squared minus 4x plus 3 is 0. Right? Which is the same as if we were to factorize this, you'll get x minus 3, x minus 1. So again, x is 3 and x is 1. Right? So you want the probability when x is 3 added to the probability when x is 1. Probability when x is 3 is 1/5. X is 1 is 1/5. So that's 2/5. Actually, this shouldn't be and this should be 4. Solution is this or this. Next one. Right? Let's do 2022. All in the group, right? 2022, do the chi-square. I think we did 3 already. 3 part B. Okay. 3 part B. Try that there. 2022, right?
Yeah, so he got some. Oh, okay. I just, no, I thought you might forget, but I checked, this new kids. There's just two for one. Yeah, feet, that's it, but I didn't come in tomorrow, and I didn't do it. But yeah, it's just the, but I don't put that in seven. And, this will be one on next, one on next. Should be young, you're right. Yeah, because I was just telling them, I was like, I'm gonna check you this one, so now I'm gonna tell this. So you can decide if you wanna put that and take it off. Yeah, because that, yeah, because she just added something. I did that, that's very long. So you are really good one. Right? So this, I don't know if I'm nice, it's really like, well, that's what's on. Because I think how would it be? I don't know if you know the double.
All right, so how this look? They gave you birds, bird types, known proportion, number in a sample. right? They gave you all the bird types, A, B, C, D, the known proportion, that's the percentage. So that's like what the probability of finding that bird, 0.01, 0.15, and so on, and then number they get in the sample. See the null hypothesis and the alternate. What will be the null hypothesis here? What will be the null? Where? What's the null? It's in. No, the null is always they do. They are. Or the bird types follow a particular percentage proportion in the given region. So they follow that known proportion there. For you with yours, Grant. It's unequal. Okay, all right. So you kind of say that there. And then otherwise they are similarly equal. Yeah, but I suppose it's just not those proportions. You just have to be careful. Right? So yeah, we can say that the bird types in a given region follow the known percentage proportion. Right? And then the alternatives, it does not follow. All right? So the probability that we are using will be what they give us here, right? Huh? Peter? Repeated, I think I said the bird types in a given region follow the known percentage proportion. Because that's how we're going to use our p values, right? Huh? Follow the known percentage proportion. And next one, it doesn't follow. Calculate the test statistic. So what will be the observed values here earlier? In our mind sample, right? What will be the expected values? Huh? Percentage by the percentage by the total, right? Percentage by the total. So just give me an idea of what you end up with now. Maybe. Right, they give you the proportions here. So you have A, B, C, D, E, and other, right? So the observed values would have been 30, 170, 250, 350, 120, 80. And what would the expected values be? 10, 150. Is 100 to 100? 1,000. 250. Right? And then you work out the sum of your observed minus your expected squared all over that. Right? That'll be a test statistic. Are they opening out already? Yeah? How much you got? How much? 230? Oh, you have the range yet? Oh. What's the degrees of freedom? The degrees of freedom, we have 1, 2, 3, 4. We have 1, 2, 3, 4, 5, 6. So your degrees of freedom is 6 minus 1. Calculate that. So it'll be, right? State a valid conclusion for the test. What we use the chi-squared. Huh? Give one. Right, but most time when it's not given, maybe we could use 5%. Right, but if you compare here, what you will say? Doesn't follow. Doesn't follow. Right, but most times, right, most times the standard thing to use is 5%. Right, and well, you'll recognize this is more than this. Right? Let's do our paper now. Check out the rest of 2022 and see if we do everything. Yeah? All right. 2021 now. But let's do one that is a different distribution, right? Now that is like this proportion. And it was? There's a proportion, huh? Let's just do one that's a little different. Try 19. Try 19. Number 4 part B. 2019 number 4 part B. Only. But you can send back 19 in group that. Send back 19 in the group now. Okay, let's slide up. But they can get it before and say, no, nothing on the graphs. Need something. Yeah. Number 4B. Is number 4B, right? Yeah. Right, it's supposed to be a binomial. I think I told you it's a binomial. Ready? Finish it. Right, so a local manufacturing company requires that prospective employees be interviewed by 3 different executives. This enables the company to obtain a consensus evaluation of each candidate. Each executive gives the candidate either a positive, 0, or negative rating. Right, the following table is 0, 1, 2, 3, and you have all the values there, right? For greater efficiency, the director of the recruitment suggests that the interview process can, how many people is it? 100. It could be approximated by a normal distribution with P is equal, binomial, with P is equal to 0.4, that is, with a 40% chance of any candidate receiving a positive rating in any one interview. Right? So the first thing they want is the null hypothesis. What will it null be? What will it null be? X follows a binomial with n 100 and p, p 0.4. Right? Or you could put it in words. Or you could put it in words if you want. You can put it in words. You can just say the value or the distribution follows a binomial with p that and n that. Okay, you can just put it in words as well. And of course, well, the alternative right? The alternative is that it does not follow, right? Right? Does not follow this here, right? Doesn't follow that. Determine the expected value if the null hypothesis is true, right? So we have our rating. The rating is 0, 1, 2, 3. The observed values is 18, 47, 24, 11. The expected values will be n multiplied by p. So we need p, right? So that'll be 100 multiplied by the probability of x is equal to 0. How are you finding that? I'll work it out. You just find the probability using the formula, the NCR formula. What would it be? Tell them out. What's the formula of x equal to 0? 3 choose 0 by 0.6 q. Remember that? Check binomial. To the and then 0.4 to the right. This will be the probability for x equal to 0. And then multiply by 100. How much you got? Remember, you have to find the probability based on the distribution. Isn't by for all of them. Oh, okay. Now when the tell is a normal distribution, I mean a binomial, so you have to use it like that. Huh? 3 minus 0, 30%. Yeah, my R is 0. All right. How much is it? 21.6. And then you do the same thing here for 1, same thing for 2, same thing for 3. How much you got here? How much? 43.2. Remember, you had to round up to it to make sure it sums to 100, right? How much is here? And when you add it up, it should be 100, right? Right, those are the expected values, and using the 10% significant level determine whether the theory can be accepted. Right, so the set of what, 10%? How much degrees of freedom? Right, we have 1, 2, 3, 4, so that's 3. How much you got? Put the chi-squared value from the table. Yes. Table value here. 6.25. Right, that's the value from the table. And add 1. And then chi-squared test value. When you work it out, using the formula, how much you got? 5.04. 5.04. So therefore, we do not reject, right? And 5 and 6, right? So we do not reject. Because they have a conclusion. So we do not reject H naught, right? Are you okay with that? Yeah, Andy, you can handle that. Right, so remember, this probability comes from a distribution. If it's uniform, then it's the same. If it's binomial, you have to work it out for each case. Poisson, work it out for each case. All right. Take a 5 minutes and let's start some. We start some module 3. Or what's after that? Huh? I will do our next one on this one. You know what's here? Whatever you did netlify, website. Netlify or netlify or something. I don't want to apply on the people. Huh? It's a website that allows you to go to the subject topic, like on it, and it'll tell you all the past people. Netlify or something. Exactly. All right, so 19 was that. Let's do one more then. That was 19. Let's check out 18. Let me check out 17 here first. 17 is 17 is a uniform, right? They bring uniform more because it's the easier one to work out. If I see a geometric curve. I'm checking 18. I have 18. Check it for me for a second. Let's check it and see if it is. Sixteen is also again, it's any equally like this. All right, we'll together. Yeah, the full year to already advertise. Secret. I got a polyester uniform. Right, we just did 21, 19. 21 was a proportion again. All right, here to do. Go in 21, and we have one of the questions to be able to differentiate or integrate the cumulative. Go in 2021, number 3, part B. Let's do that. 2021, number 3, part B. Actually, you gotta be able to integrate. How else you get up? Yeah.
So this.
2021, number 3, part B. I'll be going to it. You will have to integrate. All the parts? Yeah, do B part 1, 2, 3, 4, 5. All the parts here. Last thing I'm done, right? You'll get a slightly longer break if you work back. So we have to be able to integrate in this one. Right? I didn't get all. Oh yeah, give me a few minutes and I'll do it. You have to integrate everything on it. Right? Yeah, they integrate. So we're doing 2021, right? Number 3B. Yes, sir. Let's put it. All right, so let's see what you're gonna. Let's see what you get, and then I'll give you a little break. Right, first thing first, what they gave you there, they gave you a PDF was, they gave you a PDF, right? They gave you the PDF. So we know that f of x is the integral of c by 3x squared plus 2x. Not integral, no, I mean. It's a bad time to have physics. We are finally seeing all kind of thing in physics or something. In fact, there's not even physics. I should teach physics first. I see what is a madness sometimes. All right. So how do we find C? Andy, in order to find C, the function or the PDF defined between 0 and 4. Yeah. So if we integrate between 0 and 4, right? If we integrate C by 3x squared plus 2x dot dx, what you'll get? 6x. You'll get, no, equal to 1. Right? So if you integrate between the values where it defined, then this integral should be 1. That's okay? Right. So now we are integrated, right? So pull out the C, and then we plug in 4 and 0. So the integral of this is x cubed, or they give you a nice integral too. The integral of x, 2x's, x squared. Right? All are equal to 1. Then you're plugging in 4 and you're plugging in 0. So C is equal to 4 cubed plus 4 squared equal to 1. No need to plug in 0, right? So C is equal to 1 over 116 plus 64. 80, 1 on 80. That's the answer? 1 on 80. Thanks. Okay? So you got to be able to integrate, right? Now they want the cumulative function. So the cumulative function, CDF, right? The CDF now is defined, the CDF is the integral of the PDF. So whenever you integrate now, and CDF is capital F, whenever you integrate between T and 0, well, C again, 1 on 80, 3x squared plus 2x, you will end up with 1 on 80 between T and 0 of x cubed plus x squared. Right? And then when you plug in T, of course, you'll get 1 on 80 by T cubed plus T squared. Right? So how do we define f of x? Right? Remember it's cumulative, right? So it looks like it's 1 on 80 by x cubed plus x squared. For values less than 0 and between 0 and 4. Between 0 and 4 is this, and more than 4 is 1. Huh? Come on. Are you okay with that? Why it's 0 and T? Because these are variable. But then you had the plus C. Let's leave out that. Yeah, but it's had a power variable. Right? The variable allows it to eliminate it. Are you okay with this? I think we did a few of these, right? A few like these, and let me sketch it. Right? When we sketch it, we had 0, some function, and 1. If you had to sketch it. If you had to sketch this, well, there's a cubic, right? So I can't really sketch that so good. So it's 0, some kind of cubic will look like this, and then it's 1. Part 3. Or they get 3 part 3. Part 3 is just integrating between 3 and 1. Or what you can do, if you don't want to integrate. Right, plug in 3 in here, plug in 1 in here and minus. Right? So you could plug in 3 in there, plug in 1 in there and minus. Same thing. Right? That's what the accumulator for. To help you eliminate that. That's okay? Come on. Huh? No, I just want to use this. Plug in 3 and 1 in. Huh? Part 2 is the answer. And if they have to sketch it, you can look something like this. Some things. I'm just not sure what this function looks like. Because it's cumulative. Remember, cumulative means you had to cater for all the values beyond this and beyond this. Or get what? Well, a standard thing. It's always 0 and 1. Always 0 and 1. And this is always less than this. And this is always more than 1. That's that. Because remember, it's probability. So the probability accumulates to 1 or 2. Right? And that's it, right? And then to get part 4, just integrate x, f of x. And then part 5 is to get variance. Are you okay with this? 1, 2, and 3? Hey, are you okay? 1, 2, and 3? Yes, sir. Okay, then remember any others? All right, so good.